All right, so what are we doing today? We are designing an access control, oh snap, this access control board here, system for the building. And I'll bring you in a second. You're gonna come on in here so you could actually see what I'm doing. Just grab some components here. You know, it's like, maybe, like, why didn't he just do this and then press record or then press stream? It's like, who knows? So we're gonna, let's pull up pull up my board. Let's bring this in. And we're just going to, okay. Now, we're gonna bring you, whoopsies, come on, dolly over. Dolly on over here. Okay, so there's a lot of stuff on the board. I'm probably just going to erase a lot of that, actually. Can we see it? Can you see it? How we looking? We got some glares. Oh God, I am blind. How am I going to do this? We'll get you closer. We're going to get you closer. That's what we do. All right. All right, I'll write stuff bigger on the board so we can see it. I guess we'll take a picture of it, even though I'm about to redo a lot of this. This was like the second plan here. All right, I'm just gonna get a good picture of this for records. Oop. Okay. So I'll bring up some of the components and some of the parts here. Got the breadboard here. I kind of took it all apart because I was going to go install it prematurely. Okay. So here's some NFC little fobs here. And we also have a couple of these NFC cards. We blurry? We're good? Try not to get too close here. Okay, so there's a couple different kinds of NFC cards. Here is the NFC reader here, just broken out to a ESP32. The ESP32 that we're using is going to be the C6. So I'm going to break. You don't got to really worry about a lot of this stuff. But this is, what is this? This is the room. Yeah, the C6. So this is a nice chip. I want to do a whole video on the new C6 itself. I mean, it's just, why would you ever, okay, I'm not going to, I was about to say something dumb and I stopped myself that time, which is rare, so round of applause. All right, so we got an NFC reader and writer. We got our controller, which is an ESP. This one's the 32U, I think, but NFC reader. And this is the, I think it's like the 352 PCA. Let's find it. Oh, man. I forgot the actual. It's like the 5321, I think. I think that it's kind of like 54. Yeah, PCA 5321. There we go. 5321. And this is I2C SPI connections. We got a backup battery We got the electromagnet here that will be controlling the front door of the studio. And I kind of taped this all together and I was moving it around. So let's go ahead and start from scratch. Let's get this all done. This has actually been up here for about a week and a half, I think. Probably gonna have to respray that. And this was a donated board, so the board is not the best at wiping away. Now, something new that I want to try that I have no experience in is the Zigbee protocol. I'm making a Zigbee mesh network, and so that's one of the design challenges that I'll have to face, but that's fine. There's plenty of documentation, tutorials, resources. It's the electronics design community is such an open community. There's the only gap to entering into it is really just bravery. Just jump into it. It's not that, I mean, I'm not a math person. I am a music person, which, you know, definitely I got the arithmetic, really good arithmetic, but I never really liked math too much, and I don't know. I think it's just because it's like, I like the physics better. I like seeing stuff move, and that's why I like more of hardware design than I do software design. But because I am making this whole thing myself, I have to dip my toes into the software side, and I will be using VS Code, using the ESP IDF, probably either the ESP IDF or I might port it through Platform IO. I haven't really thought of it. I might do a manual build, but we're just going to kind of talk over a data flow and a processing flow for all of this, so I can better design this. We call it the third iteration. I've started over. This is the third time that I'm starting over. The first time I actually had everything put together, and that was for RFID. And then I decided to go with the NFC because we're a tech studio. That's one of our things. Is we have all the good tech here. So, can we order an access control? There's great products out there, fantastic ones that have web UIs and all that, and you just buy it and put the batteries in, you enter some maybe network credentials in, maybe subscribe and enter those credentials, but that would be the easy, pragmatic, practical. I mean, it's really the best way to do it, but I want to design something. I love the ESP32 platform, and I don't know, it just seems fun and cool. Like, we got this AD2000M, and I got this off Amazon. I was just going to kind of test it out. This was going to be like just for my prototyping process. But this thing is packed with settings, like features, so many features. I can say, we can do NFC, right? NFC's got the NFC reader. I think it's actually like around. No, it's like halfway. It's actually over this. So even though there's a symbol here, you actually have to like wipe over the pin. So we can give you a unique key fob. But say someone steals that key fob. Because the key fob, you can't get around the physical access. If I have physical access to this key fob, then I'm getting in. It's a little bit too much, and I doubt we're going to actually implement it, but if you wanted to, I could put a personal pin on each one of these cards. So not only do you have to scan the physical card, you actually have to type in like I think it was up to 6 digits. So yeah, there's that, and there's also a doorbells, and all that stuff. And oh, some of my labels are coming off, which that's 12 volt DC. That's not a big one, but something that I like, that I got lucky with, is the push signal for this. Is just you pull the signal down to low, and it will, because the electromagnet is normally closed, the moment that you pull down that signal, it will open up the circuit, hence turning off the electromagnet and opening the door, and then you can kind of get yeah, you know how a door works. Why am I explaining that to you? Okay, people be moving my markers. There we go, right over here. So we're gonna squeeze. And I think I have one more marker right over here. Yes. Okay. So hopefully you will be able to see this. Let's check it out. So we have, we'll call it IoT access. Can we read that? No. Okay, we'll come down a little bit. We're a little tilted here. We're a little tilted. Maybe we weren't. We'll kill some of this. All right. I think that's, you could definitely read that. I'm going to rewrite it because the handwriting sucks. I also got to make sure that the depth of our focus is okay. So how will I do that? I need, okay. All right, so we're going to go with IoT access control. A little blurry there. I'm not a teacher, even though I would love to learn how to teach. I'm not one, so let me just put the eraser up. Let me write this so we can write more clearly. You know, when people say you write like a doctor and you kind of think like it's a compliment. Good enough. IoT access control. So what we got our main feature, the main feature is going to be NFC. What is the protocol? It's like 14403. Hold on. We're going to look this up. I believe is it ISO 14443? Is that it? Okay. ISO 14443, that's it. See, it will say So 1, 4, 4, 4, 3. So that's some of the cards. Bring this up a little bit, just a little bit closer. Okay. Got to rewrite the ISO part. There was a bug in my coffee. I'm still going to drink it. Protein. I'm going to keep rewriting because I need good. We won't even worry about the standard. We'll just say, yeah, NFC, okay? So, well, actually what we'll say is this is going to be, I believe it's called, what is this chipset? Let me see, is it PCA 5321? Or is it just PC? 5321 NFC PN532. It's the PN532. PN532. So that is going to be our NFC reader writer. Then we're going to have the ESP32. And ESP32. And this is going to be the C6, which is, it's new enough to not have crazy easy support, but there's enough, just dig into your overstack and your different forums and you'll be fine working with it. I got the Waveshare C6, which is pretty skinny. It's a lot skinnier. Let me, so here's the normal one that I'm using for the prototyping. And so that's good, but you can see that there's no built-in LEDs, but I do like the IPX port right there. It's a reverse polarity port as well, and all you do is you switch. I don't even think you have the LED the extra resistor in this. Yeah, there's just no antenna on this one. Yeah, there's no antenna because usually you have this gap above the chip and you can see the traces in there, the PCB antenna. There's none on this. It's actually, but I've used this without the external antenna and it will work in a close distance fine. But as you can see here, this fat one to the right is the 32U, which is a powerful one, but the C6 to the left, this one, sorry. One day I will have like an actual person helping me out. Where are we at? We're at right here. All right, so there's actually an RGB LED down here, which I'm going to work on getting that to do a little hello world script on that, because I would really like to see that pulse. And then I do think, yeah, there's a power LED on that side too. Actually, the BS, I believe, has at least a power LED. A great thing, great. It's the C6 kit, and this is the N8 chipset revision. Let's see if we can show you that. All right, so there we go. That is the ESP32C6. Next up, so that's going to be our controller. We're also going to have the AD 2000M, so I'll put that up there. And that's going to also be a type of controller, AD 2000M. And now this controller is going to be a offline database, essentially because it stores in flash memory the users, the whichever ID is of the card. You could read and write with it. So say if the internet goes out because the magnet is normally closed, there needs to be a good way to access it. If the ESP32 is not working, or if you can't use the PM532. So there's those three things right there. I'm not going to write these down yet, but this is a push to open. If you're inside, you can hit that. You got, of course, a backup battery for the distribution box. So I'm just going to go through the design process. Right here, right live. So these are going to be our three main, we'll call them modules. We're going to break up a couple of them. I guess we'll throw in this power supply control, which is what drives the magnet. Looks like it's just 12 volt, 3 amp output. It's got some control pins, a push pin, which is, I think the push is what we're going to be interfacing with, because that's the easiest, where you just pull down a high signal. So it might be 12 volts or whatever it is. I measured it a while ago, and I found that it was, if you pull it down, it will trigger the open circuit. But so what am I going to say here? I'll just say the AC. Let's see, there's not really it's like a cheap Chinese piece, so there's not really like a name for it. I'll just say power supply control. So PS power supply controller, or control, because that's what it says on there. Okay. So now what we're going to need is, I'm going to write a couple just different peripherals and just the extra stuff that we don't really need to interface too hard, because, like, say for the Hall effect sensor, all right, this is the Hall, we'll just call it a Hall sensor. This is what's going to detect if the door is opened or closed. And that's going to be plugged into the ESP32. Okay, Hall sensor. We're also going to need, we'll put up our rechargeable, the lead battery. So we have the backup battery. It should be a 12 volt, right? Who's texting me? Someone's hitting my phone up. Okay. People always call me, right when I start streaming, they start hitting me up. Oh, I see a mark on the lens. That doesn't look like a good mark either. I'm sorry I'm about to poke your eye right now, but there's like a, what the, that looks like marker. I swear to God, that looked like marker. Okay, so we're going to be using the SPI. So, all right, so we get the Hall effect sensor. I'm thinking that's it, right? I mean, we got the battery. I could write that down, backup battery. So, B, backup power supply. Yo, what's up, dude? I'm streaming. Yo, I'm streaming. What's up?
I was gonna ask, I got those NFC chips.
Well, come on over.
Alright, let's go.
All right. All right, so another NFC project that we have, which I don't even know if I should tell you, really. I mean, it's an easy, simple, but useful idea with NFCs. I'm gonna hold off a little bit for it. Also because this is sort of like a business and I'm not the owner of it, even though I'm really good friends with him, I'd still like to run it by him before I start divulging certain information. So I'm not gonna do that yet. I won't give it to you, I'm sorry. But yeah, there's other things, sorry. So we got the backup battery, a hall sensor, we could use the push switch. So then we got a push switch. Okay. How are we reading? How are we reading? Yeah, that's good enough. Okay. But now that's easy. We just wrote a list of things. How does all this connect? Well, I've done a lot of the work that for the version 2 that will actually be able to move over to that. So let's look up this. And then I'll throw it up on the screen real quick. We'll just add in a window. All right, let's see. This is going to come up here. Yep. All right, let me move it over here and kind of enlarge it a little bit. All right, now let's close that out. All right, so here is my ESP32, and I've already, in some of the code, assigned the SPI pins. Here we go. The Hall effect sensor is going to go to pin 11. This is stuff for this is to reset the PN532, and here we go. Here's the 532, and this is going to be all the ESP32 pins. So this connects to 6, this connects to 0. So if we look here, 6 is going to be our clock, our SPI clock signal. And then if we come over here to 6, we can see that that is the clock signal. All right, so, all right, let me get that off the screen now. All right, so this is going, I gotta think about how I'm going to position everything on here. So I think what we're going to do is, since I've already used blue for these components, I'll keep blue there. I guess I'll make green. I can make that serial. So green will be our SPI. And then red will be something. Okay, so what we have is we have the electromagnet. So let's just, here, we'll put a door. There's the door. Doesn't need to be too big. Now our door opens up from this side. That's where the handle is. And it kind of goes in away from us. Oh, how would I write that? So like if I, something like that, is that, what the heck? All right, let's get this off the screen, hold on. All right, don't look, you can't see that. You can't, it doesn't exist. It's not there, okay. Try that again. So we got a door up. How far down can I go? Okay, I'm gonna go put a door right here. All right, now we're gonna put the magnet like right here. So that is going to be our electromagnet right there. I can do better than that. So we're going to make just a little chunk of block right here, which is going to be the, we'll say, oh God, magnet. All right, good enough. So we'll say magnet right there. Okay, so we got the magnet. The magnet is going to be plugged into our PS control. So we're going to have like a little distribution box. We'll call it right here. And this is the distro box. And we're going to have a battery in here. We're going to have the ESP32 in here. All right, this might be a little too small. You know what? I think I should make this a little bigger. All right, Beetlejuice door right here. Let's see if I can square off this door a little bit. I'm not an artist here. Okay, so there's the magnet. And then we got a distribution box, right? And we'll have 1, 2, 3, 4, 5, 6, 7, 8. So here we got we could put the battery here. So we got, there we go, we got the backup power supply. So just a little mark right here that we included that. Next, we're definitely going to have a push switch. We'll put the push switch right here next to the door. And I'll just say PS. So we got the push switch, the Hall effect sensor. The Hall effect sensor, I think I'm going to try to put it somewhere close to where the magnet is, right here at the top. So then we got blue. So this is an analog signal. So we'll just we could put it right here. We can just put it along the wall on the inside, even though that's way bigger than, I mean, the actual sensor itself is itty bitty, wherever it is. Here we go. This is actually it's a breakout board. Probably has like maybe an RF filter in it. But here is just that component that's poking out that looks like almost the leads are almost touching each other. I gotta separate those. Make sure they're not touching. But so anything on this side, oops, anything on this black piece, it's going to detect a magnetic field and if it does, it'll go to 0. Otherwise, it'll be a 1. So there it is. That's the Hall effect sensor. Now next, on our board, here's the BPS. Let's put our, so the reason why I'm trying to like think about the size is because I need to write the pin connections. So there's going to be, you know, placing these diagrams and circuits are just, there's an art to it. And really it's about just draw, erase, readjust, move, repeat. Okay, let's go ahead. Let's put our, on the opposite end, outside there somewhere, we will have the PN5332, the NFC chip. So we'll put that in green. And then we'll just say this is it. This is the reader. All right, 'cause we know it's outside, so we'll just write PN532. And see, it's got an I2C pinout. It has the VCC ground SDA, the data and clock signals. Let's see, what is it set to right now? Okay, good. It is set to, what is HSU? Is that another communication protocol? Am I an idiot that I don't know what HSU is? I know what I2C and SPI is, so that's gets us there. So we'll just go here. We'll go. Okay, let's wait for that. Let's wait for those connections. And then ESP32 is going to be the ESP32 is super tiny, but we're doing this because the pins and the connections and do. Okay, so we got this board on. We got that on the board. We got the ESP on the board. We got the push switch PS. Oh, and then PSC. I'm confusing myself already. But this is going to be the controller, the PS control. Okay. And then the AD 2000M is, I don't know if we're actually going to mount that outside, but for now we'll just say it is. So this is the PN552, and now we got the AD 2000. M. So there's all of our components on the board. Now let's start connecting them. Let me reference to my Excel sheet that I put on here. So it looks like 6 is going to be SPI clock. So we'll say at pin 6. What other pins are we going to use? We're going to use 6, 0, 1, 11. All right, and note that these pins are not representative to the physical board itself. I'm just moving around them on this actual diagram. for ease. I think we're a little blurry, so I'm gonna just give this a tap. There. Okay. Next, we got 5, 3, 11, 2, 3. So then we got 2, 3. We're actually gonna erase this line right here. Then we're gonna have our 5 volts and ground. We'll put that up here. 5V, call this G for ground. Then I think we've got 21, which is going to be our signal, our SPI data signal. So yeah, 21 SS. And then we can actually close this off. Now, so those pinouts, we're also going to represent the pinouts on the PN532, but I'm only going to put the SPI pins on this. And so we got our clock, we got so we got in and out there, our signal, so we got SS, and we'll do this, how do they have it marked on here? RQ and RSO, yeah. And then we'll go 5 volts and ground. So yep, we got 4 for our SPI protocol. Of course, we have to supply power. We got these reset pins. All right, we'll start to prepare to make connections. We got our control here. It looks like we have a normally closed. We're going to use that one. We're not going to use the normally open. We're going to use 12 volts, ground and push. That's it. See? We'll put this normally closed and ground. Five volts. We'll put that up here. 5 volts and then push. All right. So right now we know push is going to go to our button here. You push this button and it opens it up. Another way we're going to do push is we're going to use, and this is new now, this is what I have not planned, is what pin I'm going to assign for the push button. I'm going to put it into the Excel sheet, the spreadsheet as well, and I think I like 10. So 10 is going to be going to our PS control push pin. Okay. So $10. All right, so I was gonna try to make it in here. Let me just move the backup battery. Make this a little bigger. And that way we can bring our push signal and actually put it in to push. All right, this might start being confusing. So there, we got our 12 volts. Oh, I got disconnected. I got disconnected. Okay. It looks like I'm streaming on, I'm on Twitch. Hold on, let me see if I can jump. Reset high. Scene transition control, stream information, restream channels. Let's see what we got here. It says we are streaming on everything, so. Okay. That green looks a little. AD 2000 dash